everyone. I am Dharshini from first year cybersecurity department. In this video, we are going to see about the inductors. An inductor is just a coil of wire which can store energy in the form of magnetic fields. An inductor produces these magnetic fields only when there is a current flowing through an inductor. The strength of the magnetic field highly depends upon the magnitude of the current flowing through the inductor and the number of turns of the inductor. A straight conductor can also produce magnetic fields when the current flows through it, but the density of these magnetic fields are quite low. But when we turn the conductor into a coil, certain number of turns, the current flowing through each turn creates its own magnetic field, which add up to form a large magnetic field. The ability to produce a strong magnetic field gives inductor a property called inductance. Inductance is the ability to oppose any change in the current which flowing through an inductor, whether it be a magnitude or in direction. Consider the inductor with a certain number of turns. When the circuit is closed, the voltage across the inductor instantly jumps to its peak value. But the current flow increases from 0 to maximum at gradual rate. To understand this, we must know about the Faraday's law of induction. Faraday's law states that if there is a changing magnetic field over a conductor, it will induce an electromagnetic force called an EMF in the conductor. The direction of this EMF always opposite to the magnetic field which created it. Due to the property of the opposing its own source of creation, this EMF is called back EMF. Here we can see that the induced EMF is directly proportional to the number of turns of the inductor and the rate of the change of the flux over a certain number of period of time, which is given as del pi by del t. The same condition occurs in this circuit, only difference in the source of the magnetic field. In the circuit, the magnetic field is created by the current flowing through the inductor. An inductor causes this lag in DC circuit only during the switching periods. There is only when the current value changes from 0 to its maximum value. As we have seen earlier, only changing magnetic field can induce back EMF in the inductor. So at the beginning of the switching period, the current which is changing in magnitude creates a magnetic field which is also continuously changing in strength. This is expand in nature. Due to this, a back EMF is induced in the inductor which opposes the cause for the magnetic field, which is the incoming current flow. This causes the lag current through an inductor. When the magnetic field reaches its maximum strength, it can no longer expand and is no more changing in nature. So the back EMF was opposing the current flow disappears and allow the current flow through the inductor. Now the inductor behaves like a simple wire, that is, it does not oppose the current flow. An interesting thing happened when we open the circuit. Even after being disconnected from the voltage source, the inductor has some current flow for a brief moment. This is due to the energy which was stored up in the magnetic field of the inductor. The magnetic field is self-sustaining as long as there is current flow through the inductor. But once the current flow stops, the strength of the magnetic field decreases from its maximum value to 0. That is, the magnetic field around the inductor is changing in nature again. As a consequence, a back EMF is induced in the inductor, but this time it helps the current flow. The direction in which the magnetic field changes decides the polarity of the back EMF. This is why the current lags behind voltage in an inductor. It's all about inductors. Thank you.